Good day, class. Today we'll be looking at the last episode on polymer reactions. It will cover condensation reactions, which will be nylon 6, nylon 16, nylon 6, and nylon and PET, polyethylene terephthalate. Then also reactions of chain polymerization. But on chain polymerization, if you can go back to my previous videos, you will see that I have discussed about chain polymerization, which um, I talk about the polystyrene, polyvinyl chloride, polyethylene, polypropylene, many like that. So you can also search online for more examples or many reactions under my chain polymerization. Then we'll be looking at the uses of polymer, then differentiation between condensation and chain polymerization, then difference between thermoplastic and then thermoset. And also lastly, we'll be looking at the polymer addictive. So let's start the class with the reaction of nylon 6,6.
All right, let's see the reaction of nylon 6,6. If you want to do nylon 6,6, you need adipic acid and S-methylene diamine. If you want to do your adipic acid, it's very simple. Just put CH2 in a bracket, CH2 into bracket 4. Then you apply carboxylic acid at these two sides of it. Then you apply another carboxylic acid here. Plus S-methylene diamine. Just diamine is like just put in bracket CH2, not to waste your book, then into 6, CH2 into 6 place 6, then with 2 in mind. I do at two sides. You can do it this way, and if you like, you can write H2, then another NH2 here as well. So now you put your arrow. This hydrogen will react with this hydroxy at the adipic acid, and another hydrogen here will react with this hydroxy at this place, then to form your nylon C6. You are going to have this to be CH2 into bracket 4, then single bond C double bond O at this side as well, C double bond O. So this one can grow from this side, and then you join this with NH CH2 into bracket 6, then NH. So this can grow from this side as well, repeating of this one again over and over to form the nylon 6 that you want to form. So this is what we call nylon 6. The reaction of nylon 6. Thank you.
So all this one they are condensation polymerization. If I want to do, I want to say plus 2H2O, but it doesn't need. There will be dropping of water molecule, small molecule in condensation polymerization. So let's look at the next one. Then let's look at the reaction of nylon 16.
If you want to form nylon 610, it is very simple. The only thing you need is sebacic acid, which is very simple. You can short the length of your reaction by saying put CH2 into bracket 8 and attach either carboxylic acid or chloride acid at this side. Let me make use of chloride acid in this reaction. C double bond O with Cl. Then plus S-methylene diamine. S-methylene diamine is just like this. Just put CH2 into bracket 6, then attach amine at the two sides. This is S-methylene diamine. Then you put your arrow. You can put this reaction here if you like in SX. So it doesn't need, but you can show it. At this point now, this hydrogen will react with this chlorine here. The second hydrogen here will react this chlorine here to form two hydrochloric acid for you to form your nylon system. So now to form your reaction, just come here by saying C double bond O with CH2 into bracket 8. So your reaction can grow from this side now. Then this one will join with this amine. Single bond NH, then single bond CH2 into bracket 6, then single bond NH. So it can grow from here, and also it can grow from here. Then you put your N. This is what we call nylon, reaction of nylon 610, that we call hexamethylene sebacamide. That's the full name of nylon system. Thank you.
If you look at this reaction very well, there's a mistake. After CH2 into bracket 8. Before I will join the hexamethylene diamine, there should be C double bond O. The Cl will not be there. Then I will now join the hexamethylene diamine into it, like C double bond O first into single bond into bracket CH2 into bracket 8 single bond CH double bond O. Then before a hexamethylene, which is NH single bond CH2 into bracket 6, then NH before we'll make that reaction. So sorry, try to amend that in your notes. Well, I'm trying to fast so that I will make the reaction fast. That is why, to save your MB. Let's look at the next reaction. Nylon 6 reaction.
Now, if you want to form the reaction of nylon 6, then just draw E caprolactam. Just start from here, this, then you put your NH. So you make sure that this ring is 7. There's double bond O here, which is a carbonic functional group. 1, 2, 3, 4, 5, 6, 7. This is what we call E caprolactam. Plus, just say with this E caprolactam is going to break down into a straight chain. Just say H2 and then start counting 1, 2, 3, 4, 5, 6, 7. So here there is carboxylic acid. Now you continue with this arrow. This one is like a first step. Then here is like the second step. So this one again will now form into nylon 6. The one we just draw now is called amino caproic acid. Amino caproic acid. Then here, then you're going to have C double bond O with open bracket CH2 into 5 places. Then NH. So this can go from here, from this side, and this can go from this side. You put N here. This is what we call nylon 6. Thank you. Or you can also do it in another way by draw your caprolactam in this way. Just show this arrow like this. Okay, put NH here. But you make sure that this thing is 7, 1, 2, 3, 4, 5, 6, 7. So here there is double bond O here, which is carboxylic acid. Here also is carboxylic acid. It's not a carbonic functional group. Then you continue by put your arrow. Then put high temperature vacuum here. High temperature vacuum. So from there, you form your nylon 6 immediately. Don't even bother to do much. By put NH single bond on bracket CH2 into 5 places. Then single bond C double bond O. Then put your growing sides here. Put your N. So nylon 6 also called polyamide 6 nylon. This is what we call nylon polyamide 6 nylon. We also call it that polyamide 6 nylon. Here should be double bond because it's carboxylic acid functional group here. So this is double bond OH.
So that's the reaction of nylon 6. So try to check it to know it in case if you're asked in the exam. Then let's look at the next one, which I believe your class can never cover more than this. And if it's covered more than this, then you should try to do more.
Good day, class. We want to show the reaction of polyethylene terephthalates. This is what you need. Terephthalic acid. Just draw benzene ring. Then, when you draw your benzene ring, you attach 2 carboxylic acid at the auto meter side. Then this will be C double bond O, then OH. This is one benzene, and then carboxylic acid, then double bond O, then hydroxy. This is what we call terephthalic acid. Then you react this one with ethylene glycol, CH2 single bond CH2. Then this carbon we have hydroxy groups. This is it. So here is ethylene glycol. Now to form your pets, this hydrogen will react with this hydroxy at this ethylene glycol. Then this hydrogen at carboxylic acid also will react with this second carboxylic hydroxy group here. Then to form a molecule of water. Then you are going to have put your arrow here to show that you want to form the reactant side. Then this will just be like you draw your benzene again. So now here you are going to have C double bond O with just only hydrogen and oxygen. Then you have here as well double bond O with only oxygen. So from there, this ethylene glycol will be able to join this bond here by saying CH2 single bond CH2. So this one now is PET. This can still grow from this side, and this also can still grow from this side. Just put in here. This is what we call PET. If you are asked to form the reaction of PET in your exam. So now we can say plus 2H2O. What this is the condensation reaction, because this is which hydrogen react with this, hydrogen react with it, then you're going to form the molecules of water that are removed from the reaction. Thank you.
So, all right, these are the reactions that I've mentioned in the beginning of class. So, let's look at the next one, which is uses of polymer. If I have to talk about uses of polymer, uh, you can click on it then to see, to bold it if you can not see it very well. There are a lot of uses of polymer based on the production. We have polypropylene. Polypropylene usually used for packaging materials in the textile industries, stationery, plastic, aircrafts, construction, rope and toys that babies are using, all those small those rubber stuff, games. Is under, we use the polypropylene to cover the um those materials. Then we also have polystyrene. Polystyrene also used for all those electrical appearance that TV, all those to package TV, all those white something that we used to package new things are polystyrene. So polystyrene also used in production of toys, container, then disposable glasses and a lot like that. Also used in the we also have polystyrene also used in insulator, for insulator, so that to prevent electric shock. We also the most important use of polyvinyl. We also have a polyvinyl chloride. We use it in the sewage pipes. All those if you look at the pipe that plumbers are using, they always put something like PVC. That PVC is called polyvinyl chloride. So for sewage pipes to dispose your feces. It is also used in the is an insulator. This one also used as an insulator, the polyvinyl chloride. Majorly all polymer materials are insulators. Polyvinyl chloride is also used in the clothing and furniture. Yes, and recently that we have discovered another thing on the polyvinyl chloride. If you look at the door and the windows that people are doing now, they are no more using glasses again. But if you look at the one they are using, it looks like glass. But if you touch it, you will discover that it is a polymer material. It's like a plastic. So it prevents heat, it prevents damage. You know, if you are using glass, people cannot play ball beside your window. But this now, people can play ball with it, and because it has a lot of resistivity to sound with other things before it can break. So it has been used for windows and door construction now. Then you have urea forming aldehyde racines. They are also polymer material that we use for adhesive mods, all those mug and many things like that. So let's look at the difference between condensation and then addition reaction. Talking about addition polymerization, monomers add to each other one at a time to form chains, a long chain. Then in condensation polymerization, monomers react with each other, releasing a small molecule. You can see in the PET and other thing that we have done in that reaction upward and up there, you will see that those monomers in the condensation reaction, they are releasing smaller particles like water and other before they form the polymer. But in addition, polymerization, there's nothing like that. Then we have unsaturated monomers, alkenes and alkyne are used as monomer in the chain polymerization. Additional polymerization are also called chain polymerization in case, so if you don't know. Um, in condensation polymerization, bifunctional or trifunctional functional groups are using. Like if you look at ethane PET now, it is combination of terephthalic acid with ethylene glycol. That one are different things entirely, different functional group. If you look at the next one is a linear or branch chains polymer structure. Additional polymerization or chain polymerization have a linear or chain or linear structure. This condensation also has a linear or branch chain polymer structure, with functional groups. So that is the difference there. Then there is an initiator required for addition polymerization. Initiator is not required in condensation polymerization. Now, I did not tell you this under addition polymerization. In addition polymerization, there are three things that are involved in addition polymerization. We have chain initiation, chain uh, chain initiation, we have chain propagation, and also we have chain termination. So there's nothing like such in there's nothing like chain initiation in condensation polymerization. Now let me explain that the three. Chain initiation is like when you start the addition polymerization, when you break double bond into one to add things. Chain propagation, when the chain is starting growing, you repeat that polymers again. Then when it's get to the point where you doesn't want that thing to grow again, you terminate the chain. That's what you call chain termination in addition polymerization. Then let's look at the initiator require, e.g. free radical. I have said that. Okay. Number 5, examples are polyethylene, polypropylene, PVC, polyvinyl chloride. We also have polyethylene, many like that in the addition polymerization. But in condensation reaction, we have example are nylon, which can be nylon C6, nylon C10, nylon C2. There are many nylons. Then we have polyesters, polycarbonates, etc. So these under chain polymerization and condensation polymerization. Then let's look at difference between thermoplastic and thermoset. They can be melted and reform multiple times. That is thermoplastic for you. If you look at all those rubber, if you put them in the fire, they are going to melt. Then you can shape it to any shape you want. When you leave it, it will cool and stable. But thermoset, it cannot be molded once once they have mold it, they cannot be removed again forever. Then number 2, molecular structure is linear or branch molecules. In that is thermoplastic. But thermoset, molecular structure is cross-link molecules. Then modelability, it can be molded and remolded. Modelability for thermoset, it can only be molded just once. Then another one, generally lower heat resistance. The thermoplastic, they have low resistance to heat, but thermoset, they are very higher heat resistance. That is why if you want to try to melt breakable and rubber, you will see that rubber will melt and the breakable will still be standing before it starts breaking and makes sounds. Then the next one is they are used for packaging, also container and pipes. Thermoplastic are adhesive coating electrical components. Examples of thermoplastic are polyethylene, polypropylene, PVC, etc. Then we have examples of thermoset are epoxy, polyethane, polyurethane, yeah, and silicone. Then it can be recycled. It's very difficult to recycle. Thermoplastic are very easy to recycle because all those plastic bottles, you can see all those Hausa people used to come and pack them in Nigeria. Many countries are now taking those sewage and they will take it back to the industry and they can remove it. That is under thermoplastic. Thermoset, they are very difficult to recycle, to melt them and to produce another thing again. Under this we have polymer additive. We are talking about polymer additives. They are chemicals that are added to the polymer to improve its properties or their property, such as the physical or chemical characteristics. So why are you talking about polymer additives is like when they want to produce polymer materials, what they add in their production to any of polymer they want to produce, to amend it, to make it to form whatever they like, they want to produce it, they want to use it for, is called polymer additive. So examples of it, number one is plasticizers. Majorly we use this one in the plastic materials, other thermoplastic materials. So because we use it for flexibility, soft viscosity, plasticity, and the friction level of the materials. The next one is dye and pigment. This one is under color, to give your polymer any color you want. We also have a flame retardant. Flame retardant, like as the word sand. Many polymer materials, they have a lot of resistivity to fire, but when the temperature is beyond their resistivity, then they attempt to catch fire. So these flame retardants are the one we use for it. We also have a blowing agent. This one is used under thermal decomposition, also for heat as well. Then you have UV stabilizer, ultraviolet light stabilizer. So majorly we use this stabilizer under the condensation polymerization. Then we also have an antioxidant. Antioxidant is just like a polymer additive that can help polymer to withstand the corrosive, like let's say oxygen in air, nitrogen in air, all those elements to withstand the rain, the sun. If you look at the chair in the stadium, a stadium that is not covered, if you discover that those chair, they don't just fade anyhow, they have a lot of resistivity to sun and the rain. Is because of antioxidant they added into the production. That is why. Then the last one here we have mercapto. Mercapto are also called mercaptan or thiose. They are functional group of sulfur, and they also called thiose. So majorly under mercaptone we have three. I just mentioned three here. Chain transfer. They are using it for chain transfer. They are using it as an antioxidant. I have mentioned above, and also they are using it also for cross-link agents. One of the mercapto or mercaptan molecule is the one I draw down here, which is a 2-mercapto N-methyl benzeamide. Thank you. Help us to share this channel to people, let them benefit from us. Subscribe to our channel and like. Give us comments if you have any issue in any chemistry course. You can just let us know. We are going to try our best to for you all. Thank you.